See this circuit. This is called a quadrature oscillator or a quadrature phase shift oscillator. This is also a type of phase shift oscillator that does not require RC network in the feedback. See, now let's understand it. These are operational amplifiers, particularly in this case they are integrators. This is an integrator in inverting form. That is, any signal that if a sinusoidal signal enters it, the output has a phase shift of plus 90 degree. Okay, output has plus 90 degree. I am writing it here only. Here we will get a plus 90 degree shift. Okay, now this is in non-inverting form. This is in inverting form. See, here plus is grounded. This is in non-inverting form. What is the meaning of non-inverting form? The meaning is here the output signal will have minus 90 degree shift. So if a sinusoidal signal enters here, it gets plus 90 degree phase shift at this point, and then after crossing this integrator, it has a minus 90 degree. So the net effect is that a signal has zero phase shift from input to output. This is the first thing to understand. Okay, clear? Second thing to understand is this feedback network. See, this is just a short circuit. We don't have any network here, RC network, as we had seen in FET or BJT type of phase shift oscillator. We had CR combination. This is just a short circuit. This means it provides unity gain. That is, the gain is unity. A is equal to 1, direct short circuit. That is, we have beta equal to minus 1. Okay. So these are the two things that you should understand. So I am re-explaining this, and then we'll see the expressions for the frequency. Again, these two are integrators. This is in inverting mode and this is in non-inverting mode. Vx is the input signal that has a plus 90 degree shift after crossing this inverting signal. Then this signal has in the next integrator, it has a minus 90 degree shift. So what we get is that a signal crossing through these two integrators has no phase shift. That is, the phase shift is 0. First thing. Second, the feedback network is a short circuit. That is unity gain. That is what is achieved by having a short circuit. That is beta equal to minus 1. And these are CR, and these all are for stabilization and biasing and all. So after the first inverter, the output was V01 or VO1, that is output of 1. So if you take VO1 by Vx, the input signal, this is given as 1 by SCR. C and R are capacitors attached to the inverters. So this is from the first inverter, or it can be written as, in terms of J, it is written as J omega CR. Okay, and VO2 by VO1, that is second one. Here what we have is 1 by SCR. Why? This gives shift of plus 90 degree and this gives minus 90 degree. So this J actually denotes plus 90 degree shift. So what we get here is minus J by omega CR for minus 90 degree. Okay. So what is the voltage gain? V output by V input, that is VO2 by Vx, output by this input. This will be this into this. Okay. So when you multiply, this is minus J square, that is 1. So 1 by omega CR square. But through that short circuit, what we have achieved is unity gain. So this is equal to 1. Okay. So what you actually get finally? You get omega is equal to 1 by CR. This is the frequency, angular frequency. So omega is 2 pi f. You can put f equal to 1 by 2 pi CR. This is the frequency. I am writing it here. F is 1 by 2 pi CR. So this is the frequency of the complete oscillator. Clear? So if you are given C and R, you can find the value of frequency of oscillation. Clear? And one more thing, why it is called quadrature? Because In the first stage, you have one signal at the output V01, then again you have a second stage where you have second output, therefore it is called quadrature, two signals and two signals. Clear? So this is another type of phase shift oscillator.